Okay, let's unpack this. You've brought us some really interesting material today, an article from the New Line Journal. It digs into a challenge I think many of us have sort of heard about, maybe in the news or just, thinking about the food we eat, the widespread use of antibiotics.
That's right. And this article really zooms in on that, specifically within livestock farming. It uses a study on weaned piglets as a key example, which is quite telling.
Yeah, and it talks about the pressures farmers are under, right? Like new regulations in places like China, the EU, pushing for changes.
Exactly. Because traditionally, farming relied pretty heavily on antibiotics, for managing health, dealing with stress in the animals.
But as the source points out, that old way, well, it's run into some pretty significant problems.
Which brings us neatly to what the article suggests as a possible path forward. Something called bacteriophages.
Bacteriophages, okay.
It calls them the natural enemy of bacteria. So hinting at a totally different kind of strategy, a new line of defense, as they put it.
A natural enemy. Intriguing. So our mission here in this deep dive is to really explore this material you've shared. We want to get to grips with why the old antibiotic way is problematic,
Right.
and then understand what these bacteriophages actually are, how they're supposed to work in this context for animal health.
And pull out the key takeaways from the sources on their potential benefits.
Exactly. And we'll try to break this down so it makes sense, even if, you're maybe newer to some of these biological ideas.
Sounds good. We're here to guide you through it.
Okay, so let's start at the beginning. The core issue the material lays out, the problem with relying so much on antibiotics in livestock.
Well, the source details how antibiotics kind of became the standard tool for preventing disease, managing stress. It was often just a routine preventative measure in many farming systems.
A way to keep animals healthy in sometimes tough conditions.
Pretty much. And the article highlights a really critical time, weaning. When young animals like piglets move off mother's milk onto solid feed.
That's a huge change for them. Stressful.
Very stressful. And traditionally, antibiotics were often given routinely right then, trying to head off things like post-weaning diarrhea. Is a really common problem.
Okay, makes sense from that perspective,
But yeah, this reliance, while it seems simple, leads to what the source calls the tragedy of antibiotic overuse. And there are several layers to this tragedy that are important to understand.
Okay, let's break those layers down, especially thinking about someone maybe exploring biology for the first time. The first big one is antimicrobial resistance.
Right, and this is probably the one you hear most about globally. It's huge. Think about it like this. Bacteria are constantly evolving, right? They reproduce super fast.
Okay.
So when you keep exposing huge populations of bacteria to the same antibiotic over and over, you're basically creating this intense pressure. Any bacteria that happen to have some tiny genetic quirk making them slightly less affected by the drug, they survive.
Survival of the fittest, but for bacteria against drugs.
Exactly. Those tougher ones survive, they multiply, they pass on that resistance trait.
Yeah.
And over time, the antibiotic just stops working against more and more strains.
It loses its power.
Completely. And the source gives a really stark number here. Experimental data showed over 60% of the E. coli and salmonella strains they tested from the control groups. These are the groups not getting the experimental phage treatment were already resistant to common antibiotics.
Wow, 60%. That tells you the problem is already widespread out there. The drugs are failing.
That's a serious issue. The target is constantly moving, so that's resistance. The second layer of this tragedy is gut microbiota disruption.
Okay, the gut. We know it's not empty, right? It's full of trillions of microbes, bacteria, other things.
Yeah.
This whole community.
A whole ecosystem, exactly. Some are potential troublemakers, but many are actually essential. They help with digestion, immunity. They form the gut microbiota.
Got it. So what do antibiotics do to that?
Well, especially the broad-spectrum ones, often used preventatively, they don't really discriminate very well. They might kill the harmful bacteria you're worried about, sure, but they also wipe out loads of the beneficial ones.
Oh. Collateral damage.
Big time. The source specifically mentions beneficial lactic acid bacteria getting knocked back. And this imbalance, it throws the whole gut ecosystem out of whack.
And what happens then, if that balance is gone?
Well, it messes up digestion, for starters. The source points out it reduces the activity of digestive enzymes, the tools the gut needs to break down food properly.
Okay.
And, kind of ironically, this disruption can actually increase the problems you were trying to prevent, like diarrhea, because the gut just isn't functioning the way it should.
Huh. So you're trying to fix diarrhea with something that ultimately damages the gut's natural ability to prevent diarrhea? That seems flawed.
It highlights a real fundamental issue with that blanket approach.
Yeah. Okay, what's the third problem area?
Stress response amplification.
Ah.
We already said weaning is stressful.
Mm-hmm.
Now, add the traditional ways antibiotics are given. Often it involves injections, or maybe forcing liquid medicine down their throat with a syringe, gavage.
Yeah, I can imagine that's not pleasant. Like getting a shot or being force-fed medicine, nobody likes that.
Exactly. So for a young animal already stressed by weaning, this adds physical discomfort, fear.
Mm.
It's another layer of stress.
And that has consequences.
Definitely. The source links this added stress and fear to things like anorexia, the animal just doesn't want to eat, and other stress behaviors. And that directly hinders their growth, their development, which, down the line, impacts the animal's well-being and the farm's bottom line.
So the treatment itself becomes a stressor that causes new problems. Not ideal.
Not at all. And then the fourth point the source raises is chronic health damage. This isn't just about the immediate effects.
Oh.
Prolonged exposure, using antibiotics repeatedly over time, you can have cumulative negative effects. It can potentially weaken the animal's organs, weaken their immune system overall.
Making them more vulnerable later on.
Yeah, more vulnerable to other diseases, things maybe not even related to why the antibiotics were given in the first place. It can even increase mortality down the road.
Wow, okay. So putting it all together, this traditional reliance on antibiotics, while maybe it seemed like a good idea initially, it leads to resistance making drugs useless, gut damage that can make animals sicker, stress from the treatment itself hurting growth, and potentially long-term weakening of the animal.
That sums it up pretty well. It really paints a clear picture of the limitations and, frankly, the unintended negative consequences of that broad-spectrum approach.
Which makes the need for alternatives pretty obvious.
Absolutely. And that leads us right back to the alternative the source is focusing on, bacteriophages.
Right, the natural enemy of bacteria. So, based just on the source material, explain simply what are these phages?
Okay, simply put, the source describes them as viruses. But wait, before you think virus bad, these are incredibly specific. They only infect and kill certain types of bacteria.
Ah, okay, so they don't harm animal cells or
Yeah.
human cells.
Nope. That's the key. They have a very narrow target, just specific bacteria.
Okay, so unlike antibiotics, which you described as more like a blanket approach or maybe a bomb, phages are more like precision-guided missiles, targeting only the enemy.
That's a great analogy. Yeah. The core idea here is shifting from that broad spectrum killing to very targeted elimination. You select or design phages that go after the specific harmful bacteria causing the problem.
While leaving the good bacteria alone.
Mostly, yes, leaving the beneficial gut residents largely untouched. The source calls this gut microbiota restoration, and is presented as a green alternative, using a natural biological agent instead of a synthetic chemical.
That targeted approach sounds much more synergistic, working with the animal's natural systems instead of against them.
That's the concept.
So how does this phage therapy actually work in practice? The source mentions that piglet study as the key evidence.
Exactly. The material digs into findings from a study at Jiangxi Agricultural University. They used phages on weaned piglets to see the real-world effects.
And one of the first things they highlight is really interesting. They call it pain-free therapy, eliminating stress-induced injury. That connects right back to the stress problem with antibiotic injections we just talked about.
It does, directly.
Yeah.
So instead of stressful injections or forcing medicine down, the study used this innovative delivery method, oral microencapsulation.
Oral microencapsulation.
Okay.
For someone new to biology, that sounds a bit complicated. How did they do that? Simply.
Yeah, it sounds techy, but the concept is pretty straightforward. Imagine putting the phages inside tiny protective capsules or beads, like really tiny.
Okay.
The source explains these coatings are specially designed to resist stomach acid. So the piglet just eats them mixed in their feed.
Ah.
The capsules protect the phages as they pass through the very acidic stomach. Then, when they reach the intestines where the problem bacteria usually live, the coating breaks down, or the phages are released.
Clever. So it's a protected delivery system. It gets the phages where they need to go without any stressful handling, no needles, no forcing liquids.
Exactly. It's not invasive. Right away, you're reducing that treatment-associated stress, which is a huge plus for animal welfare from the get-go.
That's a fantastic example of how the method of delivery can be just as important as the treatment itself. Okay, so beyond being less stressful, the study also found multifaceted improvements in the piglet's health. Let's break those down. First up, reduced diarrhea.
Right. This was a direct, measurable outcome. The source clearly states that adding phages to the piglet's diet at specific levels, they mentioned 400 to 600 milligrams per kilogram of feed, led to a statistically significant reduction in diarrhea scores compared to the piglets that didn't get phages.
Okay, and they mentioned P 0.05. You see that in studies. What does that mean in simple terms for someone maybe not used to scientific papers?
Yeah, that's a standard thing. P 0.05 basically means there's a very low probability, less than 5%, that the result they saw, the reduced diarrhea, happened just by random chance or coincidence.
But they're pretty confident the phages actually caused the improvement.
Exactly. Over 95% confident. It tells you the finding is statistically significant. It's likely a real effect of the treatment.
Got it. So a real measured drop in that major post-weaning issue. They also found improvements in what's described as gut function. They mentioned things like volatile fatty acids, VFAs, and disaccharидase activity. Sounds technical again?
It does, but let's simplify. Think about gut function. It's about how well the gut is doing its job. Those beneficial bacteria we mentioned, they produce useful stuff.
Right.
Volatile fatty acids, VFAs, are a key example. They're basically energy sources produced by good gut bacteria, really important for the health of the gut lining itself.
Okay, energy for the gut.
Right. And the study found phage treatment actually increased the levels of important VFAs like acetate and butyrate in parts of the piglet's intestine, but over 30% in some cases.
So the phages knocking out the bad guys allowed the good guys to flourish and make more of these beneficial energy compounds.
That's exactly the interpretation. It's helping restore that healthy gut ecosystem.
Okay, what about the other part? Disaccharidase activity and intestinal pH.
Right. Disaccaridases. Those are crucial digestive enzymes. They sit in the lining of the intestine. Their job is to break down complex sugars, carbohydrates from the feed, into simpler sugars that the animal's body can actually absorb and use for energy and growth.
Like little biological scissors cutting up the food?
Good way to put it. And the study found phage treatment actually boosted the activity of one of these key enzymes, sucrase, in the duodenum. That's a main part of the small intestine. Again, statistically significant, P 0.05.
So better sugar breakdown?
Better sugar breakdown. And they also found it helped lower the intestinal pH, making the environment slightly more acidic, which can also favor beneficial processes and hinder some pathogens.
Okay.
So, taken together, lower pH, better enzyme activity, it means carbohydrates are being digested and absorbed more efficiently, especially in those key upper parts of the intestine. That means better nutrient uptake overall.
So the phages aren't just stopping the bad effects like diarrhea by killing pathogens. They seem to be actively improving the whole digestive machinery's ability to process food and get nutrients out of it.
That's what the data suggests.
And that would directly impact growth, wouldn't it? Better nutrition means better growth.
Absolutely. If you're absorbing nutrients more efficiently, you get more bang for your buck from the feed. Leads to better weight gain, healthier development.
Makes sense.
And the source sums up those key conclusions from the study nicely. Phages improved growth, reduced diarrhea, regulated intestinal pH and enzymes, modulated those VFAs, enhanced disaccharidase activity. It really builds a comprehensive picture.
Yeah, it seems to move the idea from just a cool concept to, well, what the source calls evidence-based efficacy. Prove it works on multiple levels in these animals.
Exactly. It's showing a shift from just, fighting disease reactively to proactively building health right from the gut outwards.
Which feels like a much smarter long-term strategy.
And the article doesn't stop there with just the efficiency and the performance data. It actually brings in a deeper idea, restoring dignity and animal welfare.
Okay, this sounds like it's moving beyond just the science metrics.
It is. The source argues that science shouldn't only be about efficiency or productivity. It should also embody, and this is a quote, a reverence for life.
Reverence for life. That's a powerful phrase.
It connects the science back to a bigger ethical picture, doesn't it? How we view and treat the animals in our care, acknowledging their intrinsic value.
Yeah, definitely.
And the article brings in another quote, this one from researchers at Ghent University, saying, "The health of the microbiota directly determines the quality of life in animals."
Connecting the gut health directly to the animal's actual experience.
Precisely. It links all those biological benefits we just discussed. Less stress from painful treatments, a healthier gut, meaning less discomfort and disease, better digestion, directly to improving the animal's quality of life. Their lived experience. It's not just about farming metrics, it's about making their lives genuinely better.
That does feel like a fundamental shift in perspective.
It really does. The source frames this as moving away from what it calls survival provisioning, just keeping animals alive enough to serve their purpose towards dignified nurturing.
Dignified nurturing. I like that. Providing care that respects their well-being.
Exactly. Care that respects their inherent worth as living beings.
And those examples they give at the very end of the article, they really bring that idea home, make it concrete.
They do, don't they? They paint these pictures.
Yeah.
Imagining pigs not trembling in fear, waiting for an injection.
Yeah.
Or chickens that aren't suffering from drug-resistant infections we can no longer treat. Or even shrimp, just thriving naturally in clean water without needing constant chemical inputs.
Those specific images really hit home. They show what the source calls the true significance of animal welfare made possible by phage therapy. It's not abstract. It's about changing the animal's reality.
It grounds all the science in their tangible experience.
It really does. Which brings us back, I think, to you, our listener, and why exploring this material really matters.
Yeah, this topic connects to several really big, important areas you might care about. Obviously, there's that massive global challenge of antibiotic resistance, which isn't just an animal problem. It affects human medicine, too.
A huge public health issue.
Absolutely. And it touches on ethical questions about how we raise animals to food, the push towards more humane farming practices.
And just from a scientific curiosity standpoint?
Oh, definitely. It's a fascinating look at using natural biological solutions, these green alternatives. In agriculture, in biology, it opens up this incredible world of microbes, bacteria and viruses like phages.
And shows how understanding them, working with them, instead of just trying to carpet bomb everything.
Exactly. Working with them can have really profound impacts on health for animals and potentially by extension for us too.
It's a glimpse into maybe using biological systems more intelligently to solve some really complex problems we face.
For sure.
Okay, so to recap our deep dive today, based on the material you brought us, we looked at the serious problems caused by overusing antibiotics in livestock resistance, gut damage, stress, long-term health impacts.
A whole cascade of issues. Then we explored bacteriophages, these natural bacterial predators, as a targeted, less stressful biological alternative.
Right, supported by that piglet study showing real benefits. Less diarrhea, better gut health and digestion, improved growth.
Evidence-based efficacy, as this source put it.
And finally, we touched on the deeper implications the source raises, how this phage approach could support a real shift towards better animal welfare, towards that idea of dignified nurturing.
It's a compelling vision, moving beyond just efficiency.
It really is. And the source talks about that move from survival provisioning to dignified nurturing using phages, which leaves us with a thought maybe for you to mull over building on all this. How might really focusing on the health and well-being of that microscopic world inside animals, the gut microbiota, its balance, its interactions with things like phages, how might that fundamentally change our whole approach to animal care?
That's a big question.
And what could that imply down the road for how we think about human health, too?
Yeah. Focusing on the microbiome, it definitely opens up some fascinating possibilities for the future.
Definitely something to think about. Thank you for bringing this material and walking us through it today.
My pleasure. It was really interesting to discuss.